Okay, thanks for showing up tonight. We'll go ahead and let, I guess, Bill go first. So take it away, Bill.
Okay, I'll be the opener. I'm going to talk about eyepiece projection. Let me share my screen. I'll share this there. Is this visible?
Yes.
Okay, so this is a really old technique. I'm just going to go through it really quickly. Most of you probably know this topic much better than me, but I'm kind of surprised that it's not used more often with some digital SLRs. So eyepiece projection is just a very simple way to enlarge how an image is viewed. It's called positive projection method, in that it's taking an image and relaying it onto the image plane of a camera. And it was very commonly used in film in the past. But it tends to allow for significant magnification of the image. So what the trick is, you're using your eyepiece as a relay lens rather than using a Barlow lens. A Barlow lens would not be a positive projection lens. It's a negative lens. I'm not going to go into the reasoning behind that, but it is this positive lens, which means it's operating outside of prime focus. Barlow lenses are negative, so they're inside of prime focus. Eyepieces, this eyepiece projection technique also allows you to have a range of magnification, anything from 1, which is kind of uninteresting, to greater than 10. And it can be quite useful, I found, when used with a digital SLR, now that they have the 1080p video modes. So a little more explanation. When I talk about prime focus or a standard telescope, normally we have some lens or mirror and it's imaging that onto a sensor. That's the standard way. Or if you want to put a Barlow lens in, you can have your telescope, and then a Barlow is a negative lens that flattens out these rays and has the result of making the effective focal length of the telescope longer than it otherwise be, and that image falls on the sensor. Eyepiece projection is a little bit different in that the objective lens forms an image, and then you're taking that image and using an eyepiece to relay that image onto a film plane or image plane or a camera, but much enlarged. So this effective focal length really depends on the spacing of the eyepiece and the focal length. And you see the math down there that you take this distance b from the eyepiece and divide by the effective focal length of the eyepiece minus 1. That's your magnification. I'll go through an example of that. So it's really quite simple. And the f number of the system does increase, unlike in an afocal system. Your objective and your eyepiece work at the same f number. That's not the case here. You're going to significantly increase the f number of the system, similar to a Barlow, right? If you put a 2x Barlow in, your f number went up by 2. It works the same here because it's a focal-based approach. Your f number is going to go up by the magnification. I have to say, I was really amused and shocked at how many wrong internet posts there are about eyepiece projection. Such a simple thing. I'm not quite sure why we get it wrong so often, but like this diagram is a little bit humorous. Notice how the light rays come into focus, and then somehow magically the light rays bend as they leave the focal point. It doesn't work that way. They continue to be straight. The other thing was, in this diagram, I covered up the error where I put a B there. They were putting the focal length of the eyepiece. You can find all kinds of goofy equations, but that one that I'm showing is correct. I guarantee Grant's paycheck that's correct. So just to beat this to death just a little bit more. So if this were a visual system using an afocal view, you have your telescope. It forms an image where at the same place where your eyepiece focal plane is, and then that recollimates the light, and it focuses on the back of your retina using your lens. So the eyepiece focal plane and the objective lens focal plane are at the same point. And your magnification is what you're used to seeing, the ratio of the two focal lengths. In eyepiece projection, it's a little bit different. By the way, sorry for the old school drawings here. I got so annoyed with the terrible diagrams on the internet. But the focal length of the eyepiece, you notice you're just shifting that eyepiece back a little bit. And as a result, by this amount, let's say X1, then this lens, your eyepiece, is no longer set up to focus for infinity, but is acting as a magnifying relay lens. And again, there's the equation there. So it's kind of easy to guesstimate your magnification by measuring the distance from the back of your eyepiece to your image plane and dividing that by the focal length of the eyepiece, subtract 1, and you got an estimate of how much magnification that you're getting. Here's some tubes that are readily sold. I'm showing the Mead here. I like this kind of design because it's threads. It threads onto the back of a eyepiece holder on a Schmidt-Cassegrain or other kinds of adapters. So it's not one with the little thumb screws. It actually threads in. Your eyepiece goes inside the tube, and the two other knurled knobs are simply locking the slider. So this can slide back and forth so you can adjust your magnification. And the diagram on the bottom shows it with a camera. So there's an eyepiece right here at that chromed end. And on the right is mine from about a week ago, Tuesday. I was out with Jack. We were imaging Mars, and that big honking extension, that's my eyepiece projection at maximum magnification with my digital SLR on the end. Here's a view of that. It's, again, I have an eyepiece right in here, and this can slide back and forth so you can adjust your magnification to get what you want.
Man, that's a 3-foot extension tube there.
Yeah, it's really.
It looks like it's as long as a damn scope.
Yeah, so that's one of the, I think, factors to consider in this technique is I've learned the hard way. Set up your telescope with the camera, with the extension, and counterbalance, because this adds a lot of torque onto the back of the scope and will affect your balancing. So I set up my scope and I balance it. Then I take that tube off and I use my eyepiece to line up on my target and then stick that back in there. And so why would you do that? Well, the digital SLR video mode I find quite useful for planetary imaging. There's good uniformity across those sensors, very good color correction. They can now capture regularly at 1080p at 30 to 60 frames per second, and you can go straight to a memory card, or you can use external capture software. But really a nice high-speed memory card, and you've got a very simple way of capturing 30 to 60 frames per second. So with my camera, I can do 1080p at 60 frames per second with exposure times as short as 120th of a second. And you can also add audio comments to the video. So it's kind of nice just to kind of add audio notes as you're capturing. I like to think of the video mode on a camera as sort of analogous to binning. So my camera has a 6,000 by 4,000 pixel ASPC sensor, and to be 1080p, that means it's mapped into 920 by 1080 pixels. Well, that's the same effectively as 3x binning. So if you had a CCD and you binned at 3x, it's the same sort of thing. It doesn't result in exactly square pixels, but that's kind of a non-issue. So if you think about it, if you do eyepiece projection at 3x, it's going to return it to full resolution. And if you set your eyepiece projection to 7x, for my system, that means I get a resolution that's the same as if I had used a Barlow lens on a raw sensor. Sorry, I got this set to auto advance, but think about that a minute. So you're you're binning it down and then you're magnifying it back up. Well, why do you do that? Why? Because if I had captured at 6,000 by 4,000 pixels, I don't think I could do that on my camera or most digital SLRs at more than maybe a second or 2 seconds per image. But at 1080p, I can be capturing at 60 frames per second with 120th second exposure. So closer to what a Planetary camera might do. Not quite as good, but pretty good. So here's just an example. Oops.
Can you go back one? Can you go back one real quick?
I've got I recorded some audio in here.
No, that was me. I was wondering if you could go back one slide real quick.
Okay.
How many? Okay, so with this setup and Mars, you were doing Mars with this setup, right?
Yeah.
How many pixels was Mars on this camera when you got done?
Oh, I don't know, but I'm going to show you an image later.
Okay.
You can kind of guess.
Thanks.
All right. I want to delete my little audio note here so it doesn't play again. All right. So here's just an example, and I'll send the spreadsheet with the presentation if Dan wants to post it. But I've got a Schmidt-Cassegrain 2000 millimeter, so 8-inch f10. If I had put a 2x Barlow and used a Planetary camera, I'd be at f20. My blur circle due to diffraction is going to be about 27 microns. Okay, I got my raw image sensor, 6,000 by 4,000 pixels. So that's like 3.9 microns per pixel. That's pretty close to what you get with a Planetary camera. I think they're like 3.75 micron pixels. So that's if I kind of used a Planetary camera type approach, I get 6.9 pixels across the blur circle. If I do eyepiece projection with, in this example, a 10 millimeter focal length, and I shift my back focus to 84 millimeters, so I get 7.4x, blah, blah, blah. You can read all the numbers, but what I end up with is exactly the same situation. So it's taking my camera and getting the same resolution in video mode as I would have gotten in this Barlow full frame mode, but I'm doing it a lot faster.
Okay.
So you might immediately argue, wait a minute, the eyepiece is really designed for afocal use, not as a relay lens. It's not optimized for that, but it really doesn't matter. If you look at this, if you're operating at f20 to f74, aberrations are really a non-issue, and you don't need to worry about it. I've never seen that degrade the image quality. So then you can capture all that using BackyardNIKON or Backyard iOS. There's this Planetary mode, and it lets you set your parameters and so on. I would take some time and make sure you know how your camera is set up on video mode. Mine has a really nice little feature where you say you can set the video parameters to be manual. So then I can control the ISO, the aperture, the shutter, all that stuff separately, and that works quite good. So here's a couple examples. So this is a configuration I really like, which is my Schmidt-Cassegrain 8-inch f10 using eyepiece projection, having a 15 millimeter eyepiece in the tube, and I try to target about 6x. So I'm getting about 12 meter focal length f60. And on the left is Jupiter. I didn't use Jupos on this, so I'm sure I've got a little bit of rotation stuff going on. But you can see the color's pretty good, and the uniformity is quite good. And then the lower right, of course, is Mars from the 2014 opposition, and upper right is the moon, of course. Now, on Mars, you can see some chromatic differences. It's atmospheric refraction, not due to the camera. So anyway, I'd suggest trying it. It's got some advantages. You can use your existing digital SLR camera. You don't have to buy a new camera. It allows you this variable magnification depending on your target. You get a very large depth of focus, and you can capture directly to your camera's memory card. Nice high-speed way to capture video. It does have some drawbacks. As pointed out, you have that really long extension tube that adds weight and torque onto the back, so you have to counterbalance for that. And because of this F numbers, it's very sensitive to sensor dust. So you just got to make sure your sensor's clean or move the object off the dust moat. Finally, I wanted to point out this reference. Sky and Telescope has an online article you can read that does a better job than I did here of laying out how to use eyepiece projection. So that's it. It's worth giving it a try.
Hey, Bill, go back a slide. Oop, so it says you can use your existing DSLR. You got to have video mode on it, right? Something that does some good resolution in videos and fast.
Yeah, fast is the most important. So if I would, my limited experience is at least 30 frames per second. And even if it's not 1080p, if it's 1080i, that's fine. I don't think many cameras have that, but even 740, I found good results with 740 frame rate. So the resolution's not critical, but as you know, the high frame rate's really what's important. The higher the better, at least 30 frames per second, because that's what's kind of allowing you to steady the atmosphere.
Because I've been, and I'm trying to figure this out now. 1 divided by 0.066. So yeah, so wow, really, it's only 15 frames a second. So you said 1/60th?
A 60th of a second, yeah. So 60 frames per second is what my camera.
16 milliseconds. Yeah, okay. Yeah, the seeing. Yeah. I gotta turn the gain way up so I can get my shutter speed way down to about 15 milliseconds. When I get up to about 30, 40 milliseconds, the seeing tends to really make things bad.
Yeah.
All right. So the question, so on my camera, what happens is I get the 15 millisecond shutter, but it takes a while for this thing to save the data and then get to the next exposure. So it always works on fire capture always shows me getting like 10 frames per second. But each of those frames is a 15 millisecond shot. So does your camera work the same way? So you're getting 60 frames a second at that 16 millisecond exposure?
Yeah, you get it's adjustable. So you can set it for 60 frames per second and a 60-second shutter. So essentially every frame is a separate exposure. On mine, you can even set it to 30, effectively setting the shutter speed at 30 frames per second, even though it's recording at 60. That would be more for action shots where things are moving. Well, no, it would be to smooth out video. No application for astronomy, I don't think. But what does help a lot is the other direction. So I can do 60 frames per second, but I can have a 120th of a second shutter speed. So that's where it really comes in.
Because that goes to the resulting image. I'm not sure how to put it, but the image brightness.
Yes.
So the question is, I don't know. I'm not sure how to talk about it without actually being able to see something.
Yeah, well, I just experiment with it. So like the other night I was at Bremelseek taking those Mars images, and I started at a 30th of a second and 6400 ISO, and I was bleaching stuff out. So it went up to 120th of a second, and it looked a little noisy, and I just played around a bit and found that an 80th of a second shutter speed worked really well.
At what ISO?
6400. No, that's not true. I started there and then I dropped it to 1600. So an 80th of a second at 1600 ISO worked well for getting some raw data from there.
Do you have any images from last week?
I do. I don't have them with me. I'll post one. Wasn't real happy with the result, but I'm not much of a planetary imager.
Well, anything you got is good.
Bill, so So I know your presentation talks about DSLR, but would this also work with like a ZWO CMOS?
Someone's talking, but I can't hear them.
Oh,
It's Dale, but he's way, yeah.
I'm way out there. Hopefully you can hear me now.
A little
You're
bit.
still real faint, Dale.
Really?
Turn your mic volume up.
Well, okay. Not sure what's going on here, but
Okay, I guess I'll turn my speakers way up here.
I don't see him talking now because I can see his microphone from here.
Yeah.
okay. Well, shoot.
Okay, I'm gonna turn. I should turn my volume on my speaker up. Bill, when you answer, talk real low, would you? Otherwise, I'm gonna be able to hear Dale, but when you talk, Bill, it's just gonna blow my ears away.
Can you hear me?
Again, yeah. Can you hear him, Bill?
Can you hear me?
Oh, Bill, your mic is muted.
You're muted.
I hear him very, very faintly.
Hmm. Not sure what's on here.
Dale, maybe you could type your question into the chat.
That's what I'm gonna do.
Yeah, I just opened up my chat window so I can see it.
Okay.
Bill, while we're waiting for Dale to type that in.
Yeah.
So when you do a 3x projection, is that like a 3 square loss of light?
It's actually a 9x. Yeah, it goes by the square.
Okay.
Yeah, it's like just like f-stops. No, so
Alright.
the question from Dale was, I know your presentation was about digital SLRs, but would this also work for a ZWO CMOS? Yes, it would. It would work quite well, but I think there might be some diminishing returns, and that gets to something some people call pseudo magnification. When you enlarge, in fact, I'm going to change my answer and say it's probably not a good idea for a CMOS camera that's for astronomy use. And the reason is you can make the image bigger, but you're also making the blur bigger, and you didn't really get anywhere. So it will work, but I don't know that it's better than using a Barlow. The reason it's helpful with a digital SLR is because the camera is taking the CMOS resolution and binning it. And so the effect of the Barlow is to unbin it. With the CMOS, the ZWO CMOS, it didn't get binned in the first place, so you don't need to go through all this work.
What if you turn binning on the CMOS?
So if you turn the binning on, then using this would help to unbin it, but it'd be easier just to turn the binning off. The thing about the a dedicated Planetary camera, as I understand it, those have really high frame rates, and you're getting the full frame at the high frame rate with the small pixels. So really no reason to use eyepiece projection. The Barlows work quite well. It's just in the situation where you're trying to use a digital SLR in video mode. It's mapping your pixels into bigger pixels, and so you're trying to unmap it.
Dan, would you call the ZWO cameras a dedicated Planetary?
Yeah, definitely.
Okay.
Hey, Bill, this is Joe, and I've got two questions about focus. One is once you get the eyepiece in focus, then where you place the camera sensor, is it basically in focus all the time, no matter where it is behind the eyepiece? Or is there a focal plane concept that you're still trying to find with the camera sensor?
It needs to be focused. It won't be in focus originally. So the camera will need to move. So when you move the eyepiece back to create the relay lens effect, that is gonna, the more you move it back, the more you need to move your camera forward. The more you move your eyepiece lens forward, the more you need to move your camera back. So I kind of initially set it up, at least, by eye, so I'm centered. I can see so I'm gonna big blurry spot on my camera, and then I adjust the focus to bring it in.
So you're essentially moving, you essentially have to move both in order to find an ideal focus for the sensor, sounds like.
Not really. What I do is I first set the eyepiece to give me, just guessing what magnification I want to get. I usually target around 6x. And then I kind of lock it down, attach my camera, and then I use focus from then on, and I never adjust the tube. Now, I will say, like when I was looking at Mars, you're obviously having a very narrow field of view when you increase your magnification this much. And I'm sure you've experienced that with planetary cameras. So a lot of times I like to start at the lowest possible magnification. So I take my tube, this tube, and I put my eyepiece in there. It's locked in. I shove this tube all the way forward and lock it. So I'm at my lowest possible magnification. Attach my camera. So I've got the widest field of view I can get, and I just center it up. I don't worry about focus. Then I unload this, extend it to wherever I want to be for magnification, and then focus. And once you do that, you never need to move that eyepiece again. You only need to adjust like the Schmidt-Cassegrain focus. So I don't iterate between the two. I usually just one time set the magnification I want, and then I adjust the focus from there.
So then when you actually do the focus, is it just you're eyeballing it basically, or is there any other sort of mechanical or trickery that you can use to achieve focus, the optimum focus?
Oh, you're asking the wrong person. I sometimes call myself Mr. Defocus because I'm so crummy at focusing images. I can't tell you how many frames I throw out because I didn't focus carefully, but I do it by eye. Now, what's nice on the preview screen on cameras, right? There's that zoom in feature. So mine, I can zoom in 2 or 3 times and adjust the focus. And like a lot of you, I'll look for an edge feature on the edge of the planet, the limb, try to get that limb in focus, and then I'm ready to go.
So with third question, with Planetary, I've only done a little bit of it, but is it logical to assume that if you pointed at a star and tried to achieve the most, minimal star point sort of view, that would be basically the same focus point for planet? Or
Yes.
is the distance still going to, between the two, still going to play a factor?
No, you'll be perfectly fine.
Right.
That works very well. The problem is the star is often much dimmer than the planet, and you're working at really high magnification. So sometimes that can get frustrating. What I like to do, if it's around, is use the moon, because you got this big target, it's certainly bright. You can see black-white craters, and boy, if you focus on the moon, you get it really good and sharp. Then slew over to a planet, and you're ready to go.
So you're saying that like a magnitude 1, magnitude 0 star like Vega is too dim?
Yeah, that would work. I haven't really tried Vega. I've tried more like a nearby star, and I didn't get good results. But you're probably right. Probably Vega would work.
Or a -1 Polaris. I mean, that's always
Curious,
right there.
yeah.
If you can, so that'd be a good question: is can you see Polaris in your camera? Can you get your scope to point at that? And if you can, then you can focus there and then slew back down to wherever.
Yeah.
You want to
You
go.
can do that while you're polar aligning. Yeah, it's a good thought. I'll have to try that.
Because when you're talking about magnification, and I'm wondering, how do you select your eyepiece? How do you determine the magnification? And does apparent field of view of the eyepiece have an effect on your image?
Yeah, so this little simple equation down here is how you decide the focal length of your eyepiece. Again, it's kind of trial and error, because you only have so much travel here. I think looks like 2 centimeters, maybe 3 centimeters of travel. There's there's not a lot of travel. So if you know, I would try to use the lowest focal length eyepiece I can use and still get the magnification I want. For me, that's about 15 millimeters. But at times, if I'm doing the moon, I've used 20 millimeters before. And does the field stop matter in the eyepiece, in the apparent field of view of the eyepiece? Nope. Because you're working at these really high F numbers and high magnification and a narrow field of view because of the planet, it doesn't really affect things. Now, what it could affect, it wouldn't affect that either. No, I mean, the fields of view are just so small that the eyepiece field of view for me hasn't been a factor.
Okay.
Bill, got a question. When you're adjusting the magnification, say from 2x to 10x, and sliding that along those 3 centimeters, is that pretty much a linear change in magnification with distance there, or is it something more complicated?
Yeah, you can. It's linear with the back focus. You can see that in that little equation at the bottom of the screen. So yeah, it's linear with that spacing, but it's not linear with the eyepiece. So if you go with as you change the eyepiece focal length, you're gonna shift the scale a little bit more. But it's linear with spacing. So I don't know what this is, but I can probably get about a 2x range out of this arrangement.
Okay.
So really, this just sounds like a spreadsheet. I mean, you can dump some numbers into a spreadsheet, and then you can calibrate a number of eyepieces, right? I mean,
yep, that's the way I do it. I just have a little spreadsheet I use.
So if you put up a known scale, let's say 100 yards, would that be a way to calibrate your stuff during the day so that you know what to go? Ooh, what was that?
I was gonna show you the spreadsheet.
Yeah.
Yeah, this is just the spreadsheet I use. So if I plug in, different focal length eyepiece, it runs through all the numbers for me.
Okay.
But I'm sorry, you were asking a question or making a statement?
Yeah, I'm wondering, can you use a scale at a known distance to calibrate your eyepieces and find out where your magnifications are?
Yeah, it certainly needs to be quite far away, but you can. The other way I've just done it is, this is a little bit of a circular logic, but if I'm imaging Mars, I'll look up from the NASA website what the diameter of Mars was, and then I look at how many pixels it was across Mars, and I know my magnification from that.
I'm trying to think. Can you do a drift test?
Yes, you could. That's a good thought too. I didn't think of that. You can definitely do a drift test.
And then that number, the seconds would tell you what your magnification is.
Yep, that's right.
Yeah. Okay. Okay. So there's a couple of different ways of calibrating your eyepieces, and on your eyepiece holder. Do they have like an index, a scale on there, so that as you're moving it back and forth, you got some numbers to actually note?
I don't think I've seen that. That's a really good idea. It'd be super easy to etch in a scale, but I'm looking at the samples and I don't see that. That's a really good idea. It'd be nice too. You set up in advance. You could go to line 2.2 for focal length 15 millimeter eyepiece. Yeah, that would work out really well.
But
I better stop because I think there's another presenter that's our featured presenter. But anyway, you can post some questions on the forum and I'll ask them.
Once Dan comes back from the bathroom, he'll cut us off. We lost some people.
Wow, I have that effect, I'm told.
There's a big, sorry guys, big thunder and lightning storm happening down here in the city.
Oh,
Lighting up.
Greg Ruppel is out in New Mexico, or New Mexico, Arizona. New Mexico, right?
He's out near Tucson.
Arizona. Okay.
okay, Dan, I'm done. If you want to start your main presenter.
That was you.
That was you.
Oh, sorry. Okay, I didn't.
Hey,
mean
hey,
to
Bill.
stop the question.
Thanks,
You don't
Bill.
know who the
Appreciate
main
it.
presenter is, you're it.
I would have added some fluff.
I can keep talking about this. I can keep asking questions. So.
I want to hear more about the M31 image from Mike.
Yeah.
What more do you guys want to hear?
How you fought your way through what your problems were and how you figured out what to do about it. You were mentioning the color wasn't aligning with the luminance as you stitched it together.
Yeah, I'm not. So when I go to combine, so I'm not sure what the best workflow is, but I have my DSLR image, which is color, and then I debayer it, and that separates it into the RGB channels. And then at that point, I extract the luminance frame and PixInsight from that. And so I had, for this image, it was like 2 main panels. And then I took another kind of set with M31 centered at 60-second exposures to do HDR with the core. So those 3 sets. And then, so I extract the luminance from the RGB, and then I stitched together the RGB linear data into the mosaic, and I stitched together the luminance linear data into the mosaic. And so then I go through and process them all separately as if they were single frame. But yeah, when I go to recombine them, I often get these stars that look like on the left-hand side is yellow and on the right-hand side is blue. And if you do the chrominance noise reduction in PixInsight, that usually gets rid of that shading. Sorry, I'm not talking about this in very scientific terms because it's mostly just trial and error what I'm doing and reporting what I see. But yeah, for M32, which is the tiny satellite galaxy, it was doing the same thing that the stars were, where I had like a yellow half and a blue half of this bright elliptical galaxy. And yeah, the noise reduction wasn't getting rid of it. And so I could go in with like more specific masking and kind of, blur the coloring in that area a little bit, but I don't know. I'm reluctant for personal, I guess, aesthetics to do like masking one area and changing the colors in it, because then I feel like it's getting too much like I'm, picking each pixel color, down to that level.
So
Oh,
Mike,
thanks, Bill.
this is Joe, and I've been kind of struggling with similar star colors where it almost looks like you're getting a prism effect or something in the stars, but they tend to be very white. And I'm doing it with color filters. And I've noticed, so part of it's also driven by the fact that being at a dark sky side, I'm trying to go deeper and deeper because I don't have light pollution to deal with. And I've been noticing that the imaging, the targets that I've done this on, that when I look at the individual color images that are stacked, they all have max value. In other words, 65,000 bits, or in PixInsight, they all have a value of 1 in the star center, or maybe most of the star. Whereas everything else that's more of a true color coming through is between 0 and less than 1. And my theory, and I'm trying to change my exposure rates. My theory is that when you end up overexposing, especially stars, and all the bits are basically, all the pixels are basically at max, full well, then there is no color. That's the designation of white. When you have red, green, and blue all at max value, you get white. But you could have between the filters possibly some edges of the stars that are not being quite as exposed because of the, the noise distribution, what you call it, Poisson or whatever. And so that's my theory right now. And I'm starting to back off on exposure a lot more, or I'm doing a few test exposures the night before and make sure that whatever level I'm choosing, that all the things that I really want to have, good rich color are definitely below full well, exposure for those tests. And I think I'm starting to see results that I'm not getting that kind of bizarre coloration on the stars. So it could be, I know you're doing DSL, which is a one-shot color sort of thing, but maybe you're still overexposing those particular spots. And when you debar it and pull it apart and then put it back together, you're getting that kind of bizarre color. Anyway, that's something I'm seeing right now that I'm experimenting with.
Yeah, that's interesting. It's certainly, maybe it's because it is like the stretched image. I see kind of exactly what you're describing. This is with white stars once it's stretched. So they're not overexposed in like the raw data, but then if they stretch to white, then I get this yellow and blue halo kind of. So
yeah, I think I did a presentation like a year and a half ago on that. But Joe, you're dead right that once you saturate the channels, you don't have any color anymore. It's white. So one of the things that I know people suggest when you're processing the image, particularly the color frame, is make sure you stretch it so that you're never more than 85% saturated on any one channel. I'll bore you with a little spreadsheet that I think I showed when I did that. This comes up with H alpha stretching. I'm gonna pull this luminance down. This is just a pure simulation, but if your raw data looks like to the left, you've got this fully saturated red, and as you stretch that more and more. Well, I've now stretched it to a point that my red channel, this is on a 255 scale, so my red channel saturated. So anything I do to make that brighter is just making it kind of pink salmon, because I can't make the red any redder. I can only make the green and the blue higher, and I get, at some point it just becomes kind of a white. So when, there's an optimal red, which you show on the right, that's the most you can stretch it before you've saturated the red channel. So yeah, that's the suggestion that others have made that I've stolen, is when you're stretching your image, try never to stretch it so that a channel is here, it's never more than 80% saturated, and it preserves the color. I found that when I find goofy colors in my images, which I often do, it's usually because I've overstretched a color channel.
So that adds something new to my thought that I'll have to go back and look at, and that is that you're saying that it could be the stretch that's generating the basically all white, everything at 255.
Yes.
Because I was looking at my raw images. In fact, that's what I'm doing now. I look at the raw image pre-stretch, and I'm looking for any stars or any features that are at full well capacity, and then I back off my exposure to get that. But you're introducing that idea that I could be stretching it up to that level and producing a white image and losing all the color out of it. So I'll have to go back and look at that.
Bill, this was maybe something you mentioned in an email to me, but just to see if I'm understanding it. So are you saying, so you stretch it up to this, limit to not saturate any of the channels, but then if you need beyond that, you brighten the image? Is that what you like? It's not stretching it, it's brightening it?
Well, you can change the gamma, so you can bring up the shadows, using tonal curves, but it becomes really important not to stretch the higher intensity part of it. PixInsight has a nice little stretch routine called the arc sine stretch, and if you haven't played with that on color images, it's really worth doing that, because it does a great job of stretching the low and mid tones without making the bright stuff stretched, and it preserves color much better.
I think this is also where people play with the trickery of processing everything but the stars and things like that to prevent, that way they can stretch the nebula or the galaxy and not the stars. And there's a lot of artistic pieces in that. It's, I get the feeling you don't do a whole lot of that. I don't, that's just not my style, but that's the reasoning behind things like StarNet and some of those other tools, is to be able
Yeah,
to
I
have
definitely,
reflections on the stars and manipulate everything else.
when I'm doing the saturation stuff, I do it with a a luminance mask type of thing, but
Yeah.
it exposes the stars and the nebula. I need the luminance mask because I don't know, with this one shot color, the background saturation looks really weird if I include that when I'm doing the saturation. But yeah, one of the other challenges I had with this was the HDR component too, because I wanted to do it in PixInsight, and they had this HDR composition tool to use, but yeah, it wasn't blending very well. I had to play around with the settings quite a bit to get the masking to look right. But in the end, I think it was all right. I mean, I could have gone further with compression of the dynamic range, but I don't know. I think Andromeda has a bright core, so it looks weird if you go too far. I feel like compressing the dynamic range.
It's an impressive image. I always loved seeing M31, but your image was really quite good.
Thanks. Yeah, when I was out in Colorado, you were there too, and we were both dealing with a bunch of smoke in the sky.
Yeah,
So
I had a
was
couple
like,
nights that were just pristine and just the hardest blue sky all day, and then a few days later it was terrible. I really got to appreciate what Dan said about smoke can really be a factor. I mean, it really shut down those seeing.
yeah, you had some really nice wide field shots too from where you were, and you were up at 10,000 feet, I think, right?
I was,
You were way high.
yeah, about 9,800. Yep.
Yeah.
Hey, Michael, I don't know if you can hear me.
Yeah.
Have you tried a photometric color combination?
So let's see. I do a color calibration, but I don't think it's a photometric one. I'm using some color calibration tool in PixInsight where I'm kind of setting the white point and the dark point using the background levels and that. Is that what you're talking about, Dale?
No, I'm talking about it's called photometric color calibration.
Yeah, is that so when you're using a star to set the color?
Yeah, using the stars to set the white balance essentially.
Yeah, I haven't done that yet. And I know, gosh, someone's given presentations on that. I forget if it was Dan or someone else, but I have not tried that myself.
Yeah, it's fairly easy to use.
And that kind of tool, like you plate solve your image so it picks a star for you, like that you should be using. Is that what you do?
Yeah, it does a plate solve, and then it takes the information it gets from the database that it downloads to determine what the white balance factors are for the stars in that area.
Mm-hmm.
When I've used it before, it helps to clear up a lot of color issues on the stars.
Yeah, I think it's a good thing for me to try with this too. So thanks, Dale.
Hey, not to drone on too much about colors, although I get kind of excited about this topic, but I'll show you this example. Hopefully I can find it. My wife has a vinyl business where she, here it is. Let me share this. Where she's got all these color vinyls that make a great color test pattern, and they're round, so you get the effect too of different luminosities. I'm going to share. Not that. Can you see this?
It's your spreadsheet again.
Here we go. That should do it. So the center panel is a properly exposed color pattern. So think of grayscale kind of at the top, and then of course the colors. On the left is underexposed. So this is, the colors are saturated, but the luminosity is so low, it's really hard to separate out some of the colors, particularly the blues and the blacks. On the right, it's overexposed. So the red channel, I intentionally overexposed it so that the channel started to saturate, and there again, you lose color. So, you know, if it's underexposed, color's not good. If it's overexposed, color's not good. You're trying to keep the colors in that linear range so that you can really discriminate them. And what I found I was doing was I was overstretching and producing the effect on the right with my color frames.
Bill, quick.
Yeah.
So I've always kind of underexposed, knowing that I can get a better exposure by pushing a little bit, as opposed to overexposing and then trying to pull it back.
That's what I read, and finally someone told me to do that, and that worked for me.
Okay, so it's better to underexpose than to overexpose.
Yes, because you can stretch it up. Good point. Yeah.
Thanks.
Okay. I guess let's let Dave Wood go. He was going to talk about imaging in Mars.
Yeah, this will be a little bit different take on imaging Mars from my front yard. Let me get this slideshow up here and share the screen. A moment. Give me a second here. Looks like I've lost it. Can you hear me out there?
Yep.
Oh,
Yes.
Oh, okay, hang on. Okay. Haven't done much sharing here. All right, let's try that again.
That's pretty easy.
Am I bringing that up? That's some PowerPoint.
Yeah.
I can see that. Yep. All right. So what, as you see here, I got started in midsummer about getting excited about looking at Mars, because it's a, you know, every 2-year event, and I, you know, when I started looking into it, I realized I was going to have some problems, perhaps in getting images good enough to do this AstroLeak program. You can see the surface features to, you know, fill out the requirements. And so what I'm dealing with is some problems initially. Limited aperture. I required a 92 millimeter refractor scope, and I had an old 150 millimeter Newtonian. Real issue for me is that I got trees everywhere, really except in the ecliptic plane where I can see planets nicely over the house. But clearly you need pretty high magnification to see surface features. And when I looked through these scopes, I would see very bright red dot where Mars was. I needed to go to higher magnification. So decided mostly to use this small refractor system. It was not as quite as big an aperture as the Newtonian, but much better focuser. I have my old Newtonian needs a focusing rebuild very badly. So this is a 8 Astrotech 92 ET refractor. See the field flattener as a center equatorial mount.
Dave, are you sharing a presentation?
Yeah.
I'm just seeing your Windows Explorer.
Oh, thank you for telling me that, because I was hoping it was the PowerPoint slides. Let's see. Darn.
Probably have to unshare and then reshare or pick in the window that you want.
Thank you. Okay, stop that sharing. Window. Okay, let's try that. Am I doing any better here?
Yes.
Thank you. So there's a picture here. Telescope picture.
Yep,
I got
you
that.
see your refractor.
Thank you. Good. That should be full screen. Can you see that?
Yeah, that's good.
Perfect.
Thank you.
Good.
Great. Okay, so pretty simple refractor setup with a one-shot color ASI camera. You notice on the image there's an off-axis guider. Not really using that for Mars images. It's not really helpful for me. So
It's not helpful, or it is?
not helpful yet. Maybe someday, but so far I've not been able to get that to focus in to provide guiding. So we'll get to that. Let me. My initial main problem here, living in the trees, is that my view of Polaris is like this. There's really no way to do polar alignment from where I'm at. So I have to go with some other options. Now the Bioptron mount has some options for alignment, including looking at different stars. I can't really see those either. But you can also align on planets. If you have a view of the ecliptic, you can take, for example, Mars. And so I've made some use of that. But my main problem is, was really with the alignment and getting that good enough for high magnification kind of work. So my summary just solution here roughly is to do a rough polar alignment using my cell phone compass. Center Mars as well as I could. And then to get enough magnification, I decided to go with a fairly aggressive PowerMate type Barlow, not really a Barlow, but fairly aggressive magnification on this 92mm refractor. Put that in place, recenter it, and then begin data collection. And for me, data collection has been pretty simple at that focal length. About 4 times 30 seconds, or if the drift isn't too bad and I can keep things pretty close in the frame, like about 60 seconds total. So that's, a couple minutes of data total. The biggest problem I solved in this whole setup was discovering PIPP software, which helped me crop and center Mars when it's drifting out of the frame. Of field of view, and that was really a conundrum initially, and PIP solved that really well. After using that program, pretty standard stuff for most folks. I'm out doing this. I found AutoStacker 3 worked really well, and I just started dipping my toe in looking at Registack 6 wavelets to improve the sharpness of the image there. So I wanted to spend a little more time on PIP as a program because it was a real revelation to me. If ever, and it really made things go a lot easier if you haven't used it, you might consider it. Real easy to use and doesn't cost anything. This is the the screen where you enter your files. And I mainly just want to point out that it has a mode that was very useful to me called the join mode, in this here in the red circle, where if you have multiple files, you know, because you can't, you just need to keep things from drifting out of view, you can join them later on. Because what the program mainly does is it centers and crops your planet so that you can do stacking later effectively. When I was trying to stack directly in AutoStacker or RegiStack 6 without doing this PIP pre-processing, I was getting just terrible results. It wasn't working at all. And so, but when I got things cropped and centered, things went well. And as you can see in this screen here for the output frame, it does give you some control over what the maximum pixel value would be for our red, green, blue channels. So I generally tried to hit about 80 to 90% saturation of the red channel. The others were always lower. Now, the next screen, this is the processing controls for PIP. Just wanted to point out 3 things that are important if you're going to use this. First, on the left, is enable median noise filter. That has to be checked in my experience, or results were not very good. So this is the median noise filter is doing a great job for me in improving the image quality. The cropping is adjustable as far as the size, but this is the default, width in pixels. I usually made that about 200, just to take away some of the background. And this testing the detection threshold is pretty useful, and lets you adjust you can change the input gain and gamma correction to reach whatever target values you want for the red, green, and blue channels. As far as avoid oversaturating any one of them, like we were talking about before. Seems like a good idea. So and other than that, I've just left everything alone as default values, and mostly it works pretty well. This one just reminds me that I did ultimately start using the quality options feature, and kept it for most of the data. That's either 50% or 80, a lot of cases 80% of the frames I kept, and up to now only use this default PIP quality algorithm. Kind of curious about the others, but I haven't explored them yet. And maybe they'll be useful, maybe not at all. But I want to get to those.
I haven't explored those either, Dave.
Okay, good to hear, I guess. Well, maybe we can work on that together down the road here. Now, there's a lot of good output options. It's real easy to use. And if you're going to use WinJupos later on to align images and analyze them, it's really useful to have a compatible file name. That's a checkbox, and you can do that. But you have any and all choices of output file formats. I mostly use SER video to go into AutoStacker with. And runs pretty fast. And after that's done, you have a nice aligned video file that you can take forward into AutoStacker 3. Nothing unusual about this. This program runs fast and easy and very straightforward to use. Steps 1, 2, 3. The only thing I'm going to point out is I did like that you had you have different quality settings you can use, and there's an algorithm for picking the best quality pictures. And so this particular data set showed the difference between 20 and 80%, 20, 40, 60, 80% quality factors. And if you
Hey,
look
Dave,
at
real
those
quick.
4, yes.
Yeah, one thing I noticed on your previous slide, there's an option in PIP that will sort the frames. I'm not
Yeah, that's
exactly
that.
sure which screen it's on,
Yeah,
but
there is.
that helps.
Yeah, right there. It says reorder frames in quality order.
Yeah.
Yeah.
Yeah,
Yeah, that works really good.
you show it checked here, but when you go to the auto stacker screen, I don't
Yeah.
think that auto stacker goes, usually this quality graph, when you have that checked, it will show the best frames at the start and the worst frames at the end. So you don't see this much. It makes it easier for you to tell how many good frames you have versus bad, so to speak.
Right. Yeah.
Yeah. Yeah, I know what you mean, and I've been a little perplexed by this quality graph, and it's not varied a lot. It's just pretty flat usually, and it's not much of a gradient, which seems off. So
Yeah,
so
it's almost like it's not taking that setting or something, because mine will definitely look like the green line, so to speak. There's very little change, but that might just be difference in equipment we're using.
yeah, maybe, but I like you said, I would expect to see a gradient here as well, and this doesn't make much sense to have just a
Well,
flat all the way across.
what I see, Dave, is I'm usually going like 2,000 frames,
Yeah.
and then I have Pip save 1,000. And then when I get to auto stacker, so those vertical lines from left to right, you've got best, and then you got 75%, 50%, 25%, and then I don't know why it says 50% on the right. So yeah, so what like Dan says, when I save like 1,000 of the best, with 1,000 frames, I definitely get the hash follows the green curve. So off to the right will be really, will be those hash marks that are sitting like at 50% in your trot. Those will be way down at the bottom. Whereas on the left, I'll have very high hash lines.
Yeah, that seems like the way it should be to me as well. So perhaps the way I should be proceeding with this is to not reorder the frames. So not do a quality estimation in PIP and do that.
Oh, no. Do a quality estimation and do reorder the frames in quality order. But you're showing, what is that, 50% or just 50 frames?
This
Yeah.
percentage
Okay.
of the frames. Yeah.
And how many frames are you getting here?
This would be about a total processed of 2,000, say.
Yeah, okay. So you're getting 1,000 frames too, just like me. Yeah, okay.
Pretty similar. But I think there is a way to select the the highest quality frames that would perhaps make more sense. So that's something else I can definitely work on. So if you
Looking at that real quick, one of the things that I think could be different between ours and yours is that you're getting rid of frames at this point. And I know I don't get rid of frames until I get into auto stacker. And maybe that's the reason why yours are up and down so much, and instead of like a sine wave curve like I get.
I gotta tell you, Dan, I found out I removed frames with PIP, so it makes auto stacker run a lot faster.
Yeah.
I mean, I never really did. I originally tried to do let auto stacker run 2,000 frames, and I would take on my 4 boxes that Dave was showing, I'll do 500, 1,000, 1,500, and 2,000 frames. Man, 2,000 frames it was pretty bad. It was pretty much down around 500, 250 to 750 is where I was getting kind of the best results.
Yeah.
So I just said, okay, well, I'll just cut off half of them and let auto stacker take the best of the best. Anyway, we're walking on Dave.
Hey, no, it's all good points, and I haven't done the systematic, survey of how to process these that I would like to do, because it's let's not get it done yet, but it should be done, and because I don't want to, maybe have 2 different quality sorting algorithms bang into each other and mess each other up. I think more sense just to use one program or the other to establish what the quality is and go with that. I don't know enough about the quality algorithms to speak about it hardly. But if we go on and just look at what you get as a result from picking the top 20, 40, 60, and 80% according to auto stacker's quality estimator, Laplace delta, et cetera, whatever they call that, then you get these images here. And I'm looking at these, as I look at these, I was pretty clear that I like the look of the best 20% or 40% better than 60 and 80. So
Yeah.
I think the top two are better. I'm not sure but the difference, there's much difference between 20% and 40% of those frames going forward, but I'm happy to have tossed away the bottom two images that look fuzzier. So I got, so really almost done here. At that point, I made some initial attempts to use wavelets and Registack 6, and I think I have a long way to go there. It's helping as things are sharper, but there's also weird artifact ring thing on the outer edge, and I've got these two vertical stripes here that I can't explain unless there's some artifact of the off-axis guide or prism. I really need to work on that. So I'm going to be spending some more hard time with wavelets, and perhaps that program you mentioned, Grant, which had a wavelet function. I do see great effects from the wavelets. They are worth running because things do sharpen up, but you can also just muck things up if you go too aggressively with them. I've seen that as well. So what's next for me? Yeah, more work with Registack's wavelets, like I described, one way or the other. Try those other quality algorithms, see if it makes a difference. Maybe not, maybe yes. And then really having collected quite a few images that I haven't really processed, I need to go spend some good time with these other programs and actually understand what the surface features of Mars are that I'm looking at, and learn something about the planet and get things going for the eventual submission to the Astro League. So that's yeah, that's all I'd say, and it was been good so far, and looking forward to another couple of months of more analysis and picture taking.
Hey, Dave,
Yes.
do me a favor. Go back to your Registacks screen again. All right. Yeah. No.
That's auto stacker.
Yeah. Right there. Yeah. I noticed something there. When I'm using auto stacker, where is the sharp? Okay. Oh, you're doing a sharpened blend raw with 50%.
Well,
That never worked for me.
yeah, I've done that sometimes, and I've often not done it. I didn't see a lot of difference, really, plus or minus that checkbox.
Okay. Same with the normalized stack. I've checked that on or off and never really saw much of a difference.
Yeah, I agree, and that's been my experience as well. And as you can see below on the advanced settings, for these data, the drizzle is off.
Yes.
I played with that some, and honestly haven't seen a great benefit to that.
I think Mike K turned me off of that too. He said he had tried it, or no, maybe it was anyway, Landon, maybe they talked about the drizzle kind of made things worse. Do you get, now on my auto stacker, I get a completed image and then I get one that's sharpened by auto stacker. Do you get that? You get
only if I've checked that box. It does a sharpening function, and it'll give you two different output files.
Because I don't see that on your screen.
Oh, really? Well,
but yeah, so I'm using the sharpen feature from auto stacker, and I really, quite honestly, I've never gotten as good of results with the basic image out of auto stacker as when I use the sharpened version from it.
mm-hmm.
The sharpened version always gives me much better results after I process that a little bit more. So
okay, well, I definitely will play around with those a little more. I haven't made an exhaustive survey of them for sure. But I'd say, for me, the towards the end of this processing, the wavelets have made the most obvious difference, but they're also, can muck up and introduce artifacts as well. So I'm a little nervous about getting too aggressive with them.
So go back to your final results. I gotta tell you, okay, your 20% looks almost as good as my best image out of that C8. I got a C8, okay, and you got a 92 millimeter refractor, and you're running a 5x Barlow or a focal extender. I'm running a 3x focal extender on my C8, and you're getting. I remember when you first sent me the images way back 2 months ago. I was like, whoa. Yeah, I mean, you're beating my C8, and
I was really happy to see anything like this, you know, actual sea surface features on the planet. I was overjoyed, really. Because otherwise I've got this really old 6-inch Newtonian that's tough to keep in collimation and tough to keep focused. So I'd much rather be using this scope for this job right now.
That's some excellent stuff, Dave.
It's fun, and it's nice to see you can do something, even though you're living in the forest.
Too bad you weren't out last Monday night when we had perfect seeing.
Yeah.
Damn, nation.
Hey, Dave, can I ask a question?
Sure.
Sorry, I missed it in your early slides. Are you doing one-shot color here, or is this?
Correct. This is a
Okay.
ASI 224 MC one-shot color camera, just to keep my life simple, and I'm gonna see what I can do, with that camera down the road for deep sky objects too. But I haven't really done much of any of those. Just concentrating on the planets for the moment, mostly.
So, yeah, I guess my question is, because you said your one thing might be with wind JUPOs, but with Mars slow rotation rate, if you're doing one-shot color, is wind JUPOs like, I assume you're going to use that for derotation, but would it even help with these images?
Well, I wasn't really thinking I needed to do anything with derotation, because there is such a slow rotation rate with Mars, and these are short data collections. So there's more of a need to define the different ephemerides of Mars and where the central meridian is, so that you can know what features of Mars you're really looking at.
That's my spreadsheet.
Yeah, there's a spreadsheet for the Astro League observing program that has about 30 things that you need to locate, different features that are well described, and get pictures of them. So you can use WinJUPOS or perhaps this other program from Sky Telescope to.
Oh, wait a minute! I sent you a spreadsheet that shows the central meridian every 15 minutes per night for 6 months.
Well, I gotta get on that, Grant. I'm gonna get after that.
Because that right there will tell you've lost some time. I mean, we've got like 2 more months left for you to get those 4 sets of images.
I know.
So I'll set you up a separate Zoom, and we'll go through that spreadsheet so that you can see when to plan your observing runs.
I need to do some more planning. Right now, my planning is just, if it's clear, go out and get some pictures.
Well, that was my original advice. Yeah, just image whenever you can. Absolutely, at least once a week.
That's pretty much it right now.
And we can always reduce. We can always go back and say, okay, the last week of August, that's your data for Syrtis Minor or Syrtis Major.
Right.
Yeah. Okay. Yeah. Just shotgun it and then decompose later.
That's where I'm at right now.
Okay. You scared me.
Yeah. Any other questions?
Oh, good work, man.
Yeah, these are all really good. These are, once
Very
the dust
interesting.
storm happened, in 2018, we never got anything this good after that. So,
Yeah.
Because there was a
Dave,
dust
I have
storm.
to echo what Grant said. I mean, you're getting better images from your system than I was getting from my 8-inch.
Yeah.
Well, I got to tell you though, I'm kind of leaning on Greg Ruppel's data that he keeps sending so nicely, because that just sort of blows my mind every time I see one of those those images from Arizona. Beautiful, beautiful stuff. But maybe I can use those higher resolution images to help calibrate what I'm seeing here a little better. You know, that might.
I use Greg's image as my luminance frame, and I just add the color. No, just
There you go.
Paint shop is wonderful. Photoshop is wonderful.
All right, I'll share this stuff, but I guess we'll have it for later.
Yeah, it feels good being.
Thanks, Dave. Thanks, Bill. Video's not on. I was wondering, anybody else have anything they want to talk about tonight?
Hey, Dan, Mark Shea here. I got a question I was hoping somebody could help me out with. It's an optics problem.
Bill Newbert.
So I'm trying to image with a little baby refractor, and I'm using an Astrotech 0.8 reducer flattener. And I'm getting what I would call coma in the corners. It's not your typical field curvature. You know, normal field curvature, the stars are smeared radially. And if it's overcorrected, the stars are smeared circumferentially. But this is like coma. And I can't figure out where it's coming from or why. It's symmetrical, so it's not, you know, free play causing sensor misalignment. So,
hey, Mark.
Yeah.
This Bill. My experience has been about 80% of the time when I have that problem, it's because my back spacing isn't right. One thing
Yeah.
I don't want to. I don't want
checked it though, and it's.
I'm sorry. I don't want Bill to get too far, but that particular Astrotech flattener reducer is extremely notorious for it has to be at a perfect spacing. If you're off by like less than a millimeter, it does that. And there's a lot of people that have never been able to get that particular one to work right. So I just wanted to point that out before you go further, because it's notorious. I've owned one of those, never got anything out of it. And that particular one's notorious for that kind of thing, unfortunately.
And Bill can explain why that happens.
No, I can imagine. I wouldn't have thought it'd be that sensitive, but I can understand that if the back distance is wrong, then that's the problem. So
yeah, it has to be perfect. And the one I had to be like 53 millimeters or something like that. I couldn't get to that. It was made for a 54 millimeter DSLR or something, and I couldn't get it there with my equipment. And I've talked to numerous people that have had the same kind of issue. And so I think you're fighting a lot of different battles with that, and you might not have all the tools to fix it, because there's issues with that particular piece of hardware.
Yeah.
And so
you definitely think it is the reducer and that distance, and not maybe a scope problem or something.
Yeah, I would think so. Bill can tell you for sure, but I know that one has spacing issues, and it's got to be perfect.
Oh, great.
Yeah, I mean, it sounds like you guys know more than me about that one. It's gosh, it must be a pretty sensitive design. Most of them can handle at least between 0.5 millimeter and 2 millimeters before there's issues. But I know, Dan, you've mentioned in the past that one's super sensitive. The only thing you might do is talk to Brendan. Or is it Landon? Landon. You know, he went through this whole regimen of taking one of his lenses and running through a series of spacings until he found out exactly where it needed to be. I don't know what shims he used or what tools he used, but his results were quite good. So probably be a long, frustrating process, but if it's a question between throwing the lens out and trying it, it might be worth it.
So Bill, is there something that can be done at a bench? Like maybe Mark can set a scope up with the thing and off in the distance have a target? Is that possible? So rather than relying on clear, steady skies, which happen once every 6 months.
Yeah, that's a good idea. If you can find something pretty far in the distance, at least a mile away,
Okay.
and kind of lay it out and try to tweak it, see what happens. It's worth a try.
And you'd be looking for what? Sharp edges across the field of view, field?
Yeah, looking
Yeah.
in the corners.
Okay.
Of course, that's harder to do without stars now that I think about it, but
Really? Oh, it is?
yeah, stars are almost a worst case situation. They're excellent for testing optical system, which is why you do the star test so often, is because if there's any misalignments or blur or whatever, you see that star smudge out.
Okay.
Whereas with like a landscape, it's harder to see the smudge.
And I guess there's no like a helical kind of device that allows you to make incremental changes in that distance without having to take things apart, putting shims in.
There are adjustable, in fact, I just bought one. There's adjustable back focal length spacers that I think OPT had one. I forget who makes it. Might be Los Mandy. I'm not sure. But there's a back focal length variable spacer.
Yeah.
So
William Optics just introduced one for this telescope, but it's like $280.
holy moly, I paid 40, which I thought was kind of pricey, but
Okay, so the answer is yes, but no. Yes, they make them, but I get them. Might as well.
Yeah, I think everyone that
one.
does that these days is using those. They sell those shim sets or whatever, and they're constantly unthreading it, putting it together.
Yeah.
It's painful. If you don't need the reducer, their Astrotech's flattener is really good. And I also have the Hotech one that's just really good too.
No, I need the reducer because I need field of view because I've got a small sensor. So
yeah, unfortunately that's the one that has a black eye on it. So it's,
yeah.
I wouldn't fight it very long.
Or, start working with 1/4 millimeter spacers and see which ones, see what combination works, right?
Yeah.
So, but you have to have good steady skies, right? Though, Dan, you got to have good seeing.
Really, I mean, just
No, not for wide field.
Yeah, just as long as you can get pinpoint stars, it's a pain to tear stuff up, plug it, to put stuff in, and then, you know what I mean? It's a slow process.
Yeah.
Especially when you can't rely on it. I wouldn't be comfortable with saying that you would ever get it flat. There was a reason why I bought mine off someone cheap and I sold it even cheaper. And there are other people that have complained about that particular one. I don't know if anyone else makes one that's both a flattener and reducer.
maybe you should have
they're
warned Mark
pretty
before
common.
you sold it to him.
I mean, I've had good luck with this before with other scopes. That was my reason I was kind of puzzled by that.
Yeah, well, if you've had luck with it before, I mean, you'll have to buy the spacer set with the little thin ones that you can just keep stacking them in there to see if it gets better or worse.
Yeah.
How many telescopes do you have? Do you have another one?
Yeah, I've got 3.
Okay, one super silly trick you could try is setting up on a long table. Take one telescope. Well, first of all, set up your refractor with your focal reducer, and instead of the camera, put like a grid paper. And then on the input side of the telescope, look into it with another telescope. So you're looking into one telescope with the other telescope.
There you go.
And what you're going to see in the eyepiece is the grid paper. And if things are at the right space, that whole grid the whole grid paper should be in focus. But if it's smeared at the edge, or the lines don't come in square or stretched
Yeah.
out, you could try shifting around the focus and see if you find a place where those lines all look right. If you do, then there's some hope of a spacer, and if not, then Dan's probably got the best advice of just move on.
Yeah, I've had success with it. Well, you know, it's not perfect because it's a generic reducer flattener. But the ones that are designed for the scope specifically work real well, obviously.
Oh, okay.
You know, this is supposed to be for f6 scopes, and it's an f6 scope more or less. So, but yeah, if the distance is that touchy, then that might be it.
So, Bill, so does F ratio, is that what, okay, so I'd ask, what do you think is the reason why this one does what it does?
You know, I don't know. I didn't think about that, but you might be right. It could be F ratio. I mean, it might be designed for well, it says it's designed for F6, but
Well, I've used it on my F7 and it just overcorrected it, but that's a different artifact.
right.
That you could just tell it's overcorrecting, but this is not an overcorrection. It's some other kind of flaw. You want me to show you an example?
Sure.
Um,
Yeah, I don't understand what would make it so sensitive. That's really weird.
You know, what's weird is their normal flattener that's not a reducer, it's good. They say it's good plus or minus 4 millimeters. And I found that it's anywhere in there, it seems to be good. It's just, this particular one is just horrible about being really, really right on.
Finicky.
are you seeing my screen?
No.
You just blocked yourself. All we see is your name.
Yeah, sorry. It went to settings and
You just canceled yourself, Mark.
I know.
So while we're waiting, Dan, so what you're telling us, the moral of your story is if anybody wants to give us one of those things, we should run away?
Yeah, I wouldn't have given that or sold it.
Because
Anyone
the
local.
logical progression here is, like you said, you bought it and you sold it for less. The logical progression is if we get one for free, we're going to have to give money and the thing to somebody else to get it off our hands.
It's just it's a frustrating piece of hardware. That's all I know, and I'm not the only one that doesn't like to fuss with that kind of stuff.
It's the Ramsden eyepiece of focal reducer.
Hey, don't knock Ramsden eyepieces, man. They were top of the line, high budget eyepieces back in the day.
Yeah, I've got a couple.
I mean, and when I'm talking about the day, I mean in Ramsden's day. Nagler came along and said, "Screw this."
Yeah.
It didn't want to share. Should I try again? I don't know why it.
I'm sorry, Bill. Blossom came along and said, "Screw this. I'm making a new lens."
Oh, there it is.
Holy crap! I've seen that. That's one of my
Yeah.
best images.
Yeah, definitely classic coma. A little bit of field curvature too.
Yeah, it's weird. So anyway.
I would, and if that was that's the whole frame, I would expect the.
No, that's not the whole frame. That's the corner.
Ah, okay. So those little comments are pointing.
Oh, what a cool image. What a bummer that that messed up your image.
Wow.
This is the flaming star?
Yeah, and tadpoles.
No,
Nice.
wait. Whoa.
Is this your coma that you're experiencing in this? Is this on a refractor or a reflector?
Yeah, it's a refractor.
Okay. Is it because I had very similar issues with my scope, which is an 80 millimeter refractor, and what I ended up having to do it was a triplet, and I had to actually send it back in to have them culminate the refractor, and that resolved the issues related to that. And so if if you're having the issues with the coma with or without that
Yeah.
reducer in there, then it's
Oh.
probably a issue with
So-
culmination that you need to fix. And if it's
Yeah.
a triplet, you have to send it in someplace to get it done because you can't use the regular culmination strategy.
Yeah, it's a doublet though. It's
Oh, well, then you should be able to do it from your house then.
yeah.
Can you go to the upper right corner?
Shoot. He goes,
And then the lower
See,
left, lower
it's
right,
more or
sorry.
less- It's more or less symmetrical.
I'm sorry, what?
It's more or less symmetrical. So
Does look
well,
like a
the
little
fact
bit
that
of
it's
tilt.
not symmetrical says something right there.
Here's a little bit of tilt. Okay, so you have a doublet. That changes the story a little bit. Dan's got a triplet. I think I'm going to guess this reducer was designed for a triplet. It would perform differently with a doublet. But go to the lower right again.
oh, that was the upper right I went to.
Yeah, I know. I meant lower.
Yeah.
Okay. Yeah, it's roughly symmetrical. So you probably don't have a lot of tilt. Yeah.
Yeah, not in this one. I have had tilt, so I know
Yeah,
that.
I'm gonna guess this really was not designed for a doublet.
So Mark, I'm guessing you do not see this coma if you leave out the
Right.
flattener reducer, correct?
I have not taken an image with the scope without the reducer.
Oh, well, get your baseline, man.
Sorry. Yeah, in fact, I was going to put my daytime camera on there just to see if there was a problem with the scope in general, but
Hey, Bill,
Yeah.
watch out. Next month, Mark will come back and say, I've got a little crow here, and show us an image without it. And it'll be just like a ton of coma in it.
yeah.
It turns out his reducer is actually removing it.
Boy, Mark, you got some great images there.
Yeah, I'm like, what the hell are you, dude?
You've been holding out on us, dude.
No, I'm not.
Yeah. I mean, you got to zoom in, what, 100x to see that little itty bitty coma that's left over?
Just crop it.
Well, it's not worth going any further with messing with it. So, I mean,
Well, hell, that image that you had was really good. I mean, better than I was ever going to get.
in the middle.
Yeah, what's wrong
Well,
with
that's
the middle?
what cropping's for.
What's what?
That's what cropping is for.
Yeah. That defeats the whole wide field part.
Right.
Anyway,
That center image is perfect.
yeah, and it's I only image from Bromoseek, so I like the easy path.
Yep.
Well, I'll try and mess with that distance, and I'll see if the scope has an issue, and let you know.
Hey, Bill,
Yes.
what's your eyepiece projection method? Let me ask a stupid question. But I'm curious as to what kind of major differences you see in quality between good eyepieces and run-of-the-mill generic serious Plossels. Does the glass quality really have a great effect, or is it tough to
It
see?
shouldn't. At f22 or f40 or f60, it's almost operating like a pinhole camera relay lens at that point. It really shouldn't matter, but I haven't really experimented with it either.
Okay. And then you're getting magnification by using an eyepiece, or you take the eyepiece out and you use a Barlow.
When I'm using my digital SLR in video mode, I use eyepiece projection because I can't get enough magnification from a Barlow.
Okay. Because I wonder if because your eyepieces generally put more glass in the light path than a Barlow.
Yeah.
And the more things you have in the light path, the more, things kind of go from good to, and so it's almost like if you could have a super long focal length and you wouldn't have to have a Barlow or an eyepiece, that would give you your best resolution image. So
In the case of the digital SLR, I think it would. If I had, if I had a super long focal length telescope, that would do the trick.
Because if you're trying to say get a 3,000 millimeter equivalent focal length, then you have maybe just a single objective with a 3,000 millimeter focal length, or a 1500 with a 2x Barlow, or an eyepiece set up to give you the 3,000. You know where I'm going? It's like the
Yeah.
just
Anyway, whatever it takes to get there. Yeah.
That's a question for later on. Well, Jim made it at the end of the show. What's going on, Jim?
They don't call me Jimbo Lake Show for nothing, do they?
Hey guys, it's been interesting, but I have to bug out.
Yep.
So thanks everybody. Appreciate it. Have a safe week. Stay
You're
healthy, stay safe, and hopefully we'll talk to you again and see everyone next month.
Yep.
Grant, I'll be in touch.
All right.
All right. Thank you, bud. Thank you, everybody. Appreciate it. Have a nice night, folks. Good night.
Thank you.
Thanks.
Yep. Yep. See you all later.
I'm going to need to bug out soon too. I got to get up really early tomorrow morning. I can leave the meeting going, or we can just close up shop. It doesn't matter to me.
Well,
I'm gonna have to head out also. I'll
Yeah,
see you
that's
all next time.
I'm gonna head out, go check out more software things. Great talking to you all. Look forward to next month.
Yeah, thanks for presenting.
Are you